Hi, good afternoon, everyone. Today, we will show you several models of predictive analytics using AI and ML. We are going to use AWS Sagemaker to predict churn from customer data in Snowflake and visualize in Tableau. We're going to look at three different approaches, starting with a high, low, and no-code solution. In the high-code solution, we are going to write our own ML code using Amazon Sagemaker Studio, S3 Datalake, and Snowflake Cloud Data Warehouse. In the low-code solution, we're using Amazon Sagemaker Autopilot to generate multiple machine learning models with different network architectures, algorithms, and hyperparameters to derive at an optimal model. And finally, in the no-code solution, we are using Amazon SageMaker AutoML with Gluon and AWS Lambda. And all the code is managed and deployed using Amazon CloudFormation CI/CD DevOps. Let's start by looking at the Cloud Data Warehouse platform. Snowflake's architecture is a hybrid of traditional shared disk database architecture and shared nothing database architecture. Snowflake processes queries using MPP, massively parallel processing compute clusters, where each node in the cluster stores a portion of the entire dataset locally. This approach offers the data management simplicity of a shared disk architecture, but with the performance and scale-out benefits of a shared nothing architecture. And this is the high-level architecture from the bottom up. In the data storage layer, the data is loaded into Snowflake. Snowflake reorganizes that data into its internal, optimized, compressed columnar format. The query processing layer processes queries using virtual warehouses. Each virtual warehouse is an MPP compute cluster composed of multiple compute nodes allocated by Snowflake from different cloud providers, such as AWS, Azure, and GCP. The cloud service layer is a collection of services that coordinate activities across Snowflake. These services tie together all of the different components of Snowflake in order to process user requests from login to query dispatch. Snowflake manages all aspects of how this data is stored. The organization, file size, structure, compression, metadata, statistics, and other aspects of data storage are handled by Snowflake. Amazon SageMaker is a fully managed service which includes labeling, data preparation, feature engineering, statistical bias detection, AutoML, training, tuning, hosting, explainability, monitoring, and workflows. SageMaker Studio is a cloud-integrated development environment, IDE, for ML coding. It supports leading machine learning frameworks such as TensorFlow, PyTorch, MXNet. We will be using these tools to code our model. In the high code track, we shall start by setting up our database and loading data into Snowflake. Understand the data using SageMaker Studio and Python Pandas, then code the ML for training and deploying the model. Once the model is deployed, we run batch predictions on the model and send the data back to Snowflake Data Warehouse. And finally, connect Tableau to Snowflake for analyzing and visualizing the data. Now in Amazon, we are going to go ahead and go to the SageMaker instance, and we have an instance here for CloudFormation. Okay, so we're going to go ahead and take a look at the Snowflake SageMaker workbook. Now, once you open the workbook, you're going to see this code, and this is called the Amazon SageMaker Studio, or it's also called the Amazon SageMaker Notebook. And this is a Python code. So we're going to, as this is a technical session, we're going to walk through the code, and we're going to look at how the data is being transformed in the code, and how it's being used in the AI training pipeline. And then we're going to go ahead and take a look at how we're using the Snowflake data warehouse to connect that data and what are the settings that we have to put in here. So that's what we're going to look at from a high level. Okay, so let's go ahead and start looking at the Amazon SageMaker machine learning component. So we're pulling in all these libraries for processing, and then we have a library for SageMaker and the predictor. And then we are going to go ahead and get started with setting up a session, setting up the roles, the region, and then we're going to go ahead and start running the script. So as you can see, we have gone through the initial steps of loading in the libraries. And once you're done loading the libraries, you can download and install any other library that's required using the pip install request. And then here is the connector for the Salesforce to Snowflake. And here's the connector in Python. Okay, should be big enough now. Now, from this connector, we go right into the executing the script here. And this is, again, running a select statement against the data warehouse. This is actually, looking at it here, you're just running a select statement on the customer churn rate and getting that data. So essentially, you're looking at this, this data here in that system. So we're connecting and taking this data. And this particular data is redacted, and this data is from a telecom company trying to predict the churn rate for their customers. And their components here, again, the phone numbers and the area codes have been redacted. What we're looking at is we're trying to see if a particular customer, based on their usage pattern, leaves or stays with the telecom company. So that's kind of the main focus, is to predict the churn rate. As you can see, here is the different fields in the data set. You have the voicemail plan, number of voicemails, how many minutes in a day, how many calls made in a day, evening minutes, evening calls, nighttime calls. So these are all attributes that we can use in our machine learning model to figure out if the customer left or if the customer stayed with the company. So as you can see, at the very end of this, there's a field here called churn, and it says false and true. So this is historical data, looking at their usage pattern, and then seeing if they left or they stayed with the company. So this could be used for many other applications. In this case, we're just showing you so many metrics just to give you an idea how you can look at all these different metrics and pass it on to a machine learning model to predict the outcome. So so let's go ahead and show you two tools that you could use for looking at the data set and trying to figure out what are the features that I want to include in my data set. And there are two tools. One is called an embedding projector, and another one is called facets. Now, with facets, one of the benefits is you can just go ahead, and this is an open source version. You can load your data, and then once you load your data, it's going to go ahead and provide you a distribution like this: the missing, the mean, the average. So it's going to give you some statistical calculations for each of the different features. And it's going to also show you if there is a normal distribution in that data, or is it skewed. And that's important to look at and make sure that when you pull in your data, there is a normal distribution in your data. And I just loaded in the telecom data. And as you can see, there's a problem here. The customer service calls are kind of skewed, which is good. You do want it to be on the lesser side. But we're also thinking there could be a correlation. If there's a lot of customer service calls, that the customer may not be satisfied, and they're calling over and over to get some service. So that's kind of an indicator that the customer may leave because they're having billing problems or they're having all these other issues. So there are a few indicators we may give more weightage. And then you can see the other ones like international calls, night charges, and minutes. And all these data is only from within the telecom. What is the external factors that influence some of these numbers? For instance, the customer may start using WhatsApp, and they really don't want to spend that international minutes. So you have to look at all those external factors and external tools that help influence these metrics. And that's where the challenge is you can't just look at your own data. You have to look at the external factors, which this data does not talk. It only talks for the data that it has, right? So that's where you bring in the data warehouse, and you can bring in other pieces of data. Like for instance, in this one, we can go ahead and bring in weather data. We can go ahead and bring in economy data, the US Census data. So we can go ahead and bring in more data, and that's what the power of Snowflake is. You can go into the data marketplace, and you can pull in the census data. You can pull in the weather. You can pull in many other pieces of data to enrich your existing data, so your decisions are much more solid. Okay, so saying that, going back into this tool, run a quick stats on your data to make sure that there's a normal distribution. And then the other component is look at your piece of data and see how it's related to other pieces of data. So for instance, when you look at it from a row, you want to go ahead and see if the data is related. Are all these numbers related? And if they are, which ones are closer than the other one? So what do you know the relationship between them, right? How do you organize the horizontal relationship between the data? And there are tools to do that. And one of the tools we're going to be using is a graph database. Or you can call it a graph network, where it maps the closest distance between two metrics. And if this metric changes, then that metric changes. If this metric changes by 10, then that metric changes by 12. And then looking at it from a large volume, you can come up with some correlations. And that, in this case, for textual data, this is very useful. For instance, I can search for, let's say, Maryland. And you can see how the embedding works, is that it automatically went ahead and brought in, let me go ahead and hide all the isolated points. So you can see here how it brought in all the other states, because based on the data that it received, it knows that, okay, if the closest I can see with Maryland is all these other states, and it kind of makes that connection. And this is very powerful when you want to do recommendations, right? And you want to look at nearest neighbor. This is a good way to organize your data and take a look at the closest count. So these are some of the visualization tools that you could use to figure out your features and to kind of organize which ones do I need to focus on. Because you can't give everything to the model, and then it'll take weeks for the model to come back. So you want to give it very specific, very focused area. So you just want to go ahead and choose, okay, I'm going to go ahead and choose these, and then I'm going to focus on that area. So you want to strategically plan that move. Now this is using embedding projects from Google and Facets. It's an open source visualization tool. So these are two tools that you could use, or you could directly go into Tableau and start doing your analysis in Tableau to figure out which ones have the most and which ones don't. And we'll take a look at that as we get deeper into the coding. Okay, so that is step one. Step one is to understand your data, to make sure that you understand which parts of your data are related, which parts not to use in your model, because it may confuse the model. Okay. Now we're going to go ahead and take a look at the code. We're connecting to the Snowflake's data warehouse, and then we're pulling in the data. This is running a select statement in the data warehouse. Again, this is a cloud data warehouse, so we're just directly connecting to this data warehouse. And we are looking at that data here inside of Amazon SageMaker. Okay, so we have this data, as we just looked at it there. And then we can rename the columns, and this is using a pandas library from Python. And we're looking at the data here after renaming the titles to be more business friendly. And then we are looking at dropping some fields. Like for instance, the phone number in this case is not really needed for our prediction. It's just extra data that we're sending into the machine learning, which we don't want to put in there. So we just took the area code and then we just cut off the phone number. So you want to remove as much irrelevant information from your data set as possible, because you don't want that to bog down your model. So we're understanding the data, and we're setting up the cleaning and setting up the data to be sent to the model for prediction. So let's go ahead and look at the next step. So this is a very interesting piece of code, which requires a lot of coding if this function didn't exist. So let's go ahead and take a closer look at this function. Now this is called a pandas library, and we're looking at a function called get dummies. And that function doesn't even do justice to what it really does. So take a look at what it does. Now, when we do machine learning, we're kind of creating a sort of decision tree, a sort of weighted average, and combining them using a graph network. So there's a lot of things that goes on in the background when you design a predictive modeling. So to do that, you want to make sure that your data does not have too many numbers, because it makes it very hard to do the decision tree based on numbers. So what we essentially do is we take these numbers and then we give it something called a one-hot encoding. And what that means is we encode the fields. Like for instance, if you take the state, we would have all the states across as a column in your data set. Instead of being in a row, it becomes a column, and then there is a flag. And this is just showing you a subset of the data. So you can see how there's flags. So if I was in Maryland, it would have a 1 for Maryland, and the rest of them would be 0. So we're essentially creating that like a leaderboard. We're creating the columnar type model. And that's because in machine learning, it's much more faster and more effective for the system to do the one-hot encoding rather than running it by columns and rows. And it's also more accurate for predictions. And that's why all this complexity of numbers and state is all being kind of flipped into just numbers across. Now, can we do that with numbers like evening minutes and day calls? No, we can't do that for these numbers. We can only do that for categorical data. So this get dummies churn, that's what it really does, is it transforms all the dimensional data into these one-hot encoding. And that's all done with just this one function from pandas library that just flips it and creates this model. Okay, so we're doing some cleanup here in pandas. And then after that, we are going in and running our training and validation and test data. So this is essentially the split of your data set. So when you're doing machine learning, you break it down into training and test and validation. So here we have taken that data, and then we're using the NP split, the NumPy library. We're using the NumPy library to split it. And as you can see, we're splitting it by 70, 90. So you can split each of those areas to 70, 30, 10, or 80, 20, or 80, 10, 10. So it depends on your data set and how it's randomly distributed. You want to set aside some data for testing, a minimum of 10% of your data for testing. You want to set that aside, and then you want to have the most amount of data for your training, and then some amount of that, at least 20 to 30% for validation. So that's what we're doing here. We're using a split function and kind of separating that data set out. We're taking that data and we're splitting it, and we're keeping it in different files. So we're calling it a train.csv, validation.csv, and test.csv. So we kind of move that out and we split it out that way. And that's the function to do that. And this is, again, standard Python scripting. Now we go into the actual guts of it. This is the line that tells Amazon that we're using the Amazon SageMaker, and we pass in this information to get the Docker image. It's a Docker container. So we're pulling in the Amazon's Docker container. And once we pull that into our instance, we are passing 2 channels. That's what they call it, 2 channels. And the channels are, one is for the training and one is for the validation. And it's just going to go ahead and pick up those 2 values that we just split here. So it's those 2 buckets are what's going to be used here. Okay? And it is parameterized, so you can change as needed. It's moved from here to here. And once you run that, essentially, you are kicking off the job. And this is the component that's actually running the job. It tells what is the size of the instance you want to run. It's a machine learning instance. It's about $2 an hour instance. So you can choose anywhere from $200 an hour all the way up to $2,000 to $3,000 an hour instance, which can run much faster on your inference. So there is anything from $5, $10 all the way up to $2,000 to $3,000 an hour instances that you'll be running. Now, you can always run it, and once the model is built, you can shut down the instance. It doesn't have to incur that charge. Okay, so let's go ahead and take a look at, briefly take a look at the different parameters that we have here. So we're passing in the role, the training instance count, the training instance type, the output path, and of course the SageMaker session, so that it kicks off a session and it runs in batches. And then if you take a look at the bottom, this is what we call the hyperparameters. Now, one of the things that we're using here is we're using this machine learning algorithm called XGB, and it's called the XGBoost. Now, for this type of data, for churn prediction, the XGBoost is the leading cutting edge algorithm to use, not a neural network or any of the other k-means algorithms. The XGBoost is the one that has proven to be on the cutting edge. So Amazon has chosen that algorithm as the go-to algorithm for any type of churn data prediction based on similar data set with other customers like Netflix and other big customers, the large volume of data. They have proven that XGBoost is the most optimized algorithm. But it's not to mention there are other algorithms we can run and we can see how it performs. Okay, so saying that, the parameters for that algorithm, this is what they call hyperparameters. This is what the data scientists have to look at. This is where you run a model, you look at it, you look at your data, and you set the different parameters based on that feature analysis, based on all the different relationships of the data. So as you keep changing these weights, your accuracy becomes higher. So that's the hyperparameter component that you can tune inside of SageMaker. Okay. Now that you have tuned the hyperparameters here, and now you want to go ahead and run your job, which is going to take about 20 to 30 minutes to run on this particular instance. So once it's run, and I ran this this morning, so once it's run, it goes through and it calculates the error and goes through again and keeps computing and adjusting the weights. And as it's done with all the calculations, it's completed it, you can see it's uploaded the training job. There you go. Here is the function that it's taking that model that is created. Again, it's a bunch of weights, right? Again, in modeling, when you look at a true table, so it is essentially a true table. So it has all these weights. It's all loaded into a CSV file. You can have a machine learning model run for 3 days and incur $12,000 in training charges. And the model, the model file would be a bunch of numbers and would be less than 100 MB. So it'd be a very small file. So essentially, once you're done and the model is there, it's a much smaller file. It's the time it takes to compute the model. Okay, so now that the model has been created, right? Now we're going to go ahead and run something called a transformer, and we're going to go ahead and start testing this model. So we're going to run this model against that test data that we have. So when we run the test data, it's going to go against our test data, and it's going to go ahead and give us a result. And it's going to give us a result of the prediction. How close was the model to the actual result? Because we already know the answer, the customer left or not. So what the model provides us is a percentage saying this customer is highly likely to leave and this customer is highly likely to stay. So that's what it does. It gives you that percentage. And that's what this is, the output of that. Okay, so now that we have looked at the output, we take the output and we push it into Snowflake. So now that we pushed it into Snowflake, we have the customer churn. This is the actual full data set. And then we have the ML result that came from it, which we pushed. So if you look at the ML result, all you're really going to see is 2 fields. So you're going to see the customer ID and the churn score, and of course the binary is the customer going to stay or is the customer going to leave? It's just a 1 or a 0, a binary classification. But our main focus is on the customer ID and the churn score. So as you can see, here's the churn score that it generated for each of the customer to see there. We have a 76% chance that this customer might leave. We have a 20% chance that this customer might leave. And that's all based on the data that we looked at, based on their usage, based on their number of calls to the customer service, and all those different aspects. Okay, so this was the high code approach. So we looked at the data. There was a lot of things you had to do. You had to fix the data, you had to organize the data, you had to go in there and clean up, you have to add the functional parameters. So this is essentially for a hardcore data scientist to look at and manage. Then this is the high code approach. Now there is another approach that's a low code approach, and then there's a no code approach, which is just you click a button and it just runs. So let's go ahead and take a look at the low code approach now that you've looked at the high code approach. And then after we're done with the low code approach, we're going to go ahead and take a look at the no code approach. Okay, so in this one, it's called Autopilot. So Autopilot is a feature that Tableau has provided so that you don't have to go through all that extra work that we just did. This is going to be a very straightforward code. So let's go ahead and take a look at this low code approach real quick. So this is, again, the same data. We're loading it in. And here what we're doing is also in this one, you do have to pass some piece of information. You do have to give it the split. How do you want your training and test data split? And then after that, you're just giving it information about the file names, where you want to store it, give some details about the file names. And then all you're really doing here is this piece. That's all you have to do. You don't have to choose what training instance. You don't have to choose what algorithm. You just have to give this piece of information. You give it the data and tell it, go figure out what I need. And all you have to do here is you have to give it the field that you want to predict. So in this case, you're saying my attribute name is churn. As you can see in your data set, the churn is that one field that we give it, explaining, hey, in this set of data, this is the prediction, and we want you to create a model so that in the future, if I give you similar piece of data, you can tell me if it's going to be a false or a true. Fairly straightforward. So we pass in that attribute and we let it run. And it runs for about 3 hours, goes out there, looks at all the different permutations and combinations, analyzes the data. Once it's done with analyzing, it does the feature engineering. Remember, we looked at that feature engineering. So it's going to figure out all the feature engineering that needs to happen. It's going to look at every component in this embedding, and it's going to figure out, okay, this is what I need to do for my data. And it passes that data information into into the feature set. And then from there, a model tuning is done. And once the model tuning is done, it completes. Once it completes, and I interrupted it after 3 hours, it would go on for 8, 9 hours. So I just stopped it at 3, and I took the best model that it provided. So for instance, it keeps running, and then it provides you a model. So it gives you all these models here, and I just took the bottom 3 models. So for 3 hours, I have a 92% accuracy. If I let it run for 8 hours, it probably is going to come closer and closer and closer. So the more time you give it, it's going to be more accurate. So you can see here a 92% on this model. So then I'm going to go ahead and take a look at that model and see what's going on. And that is the beauty of this AutoML, is without me doing anything, just passing in the data and passing in this this value, it just did everything else. It just went ahead and got everything for me. Not only that, it does something else. It actually lets you take a look inside. So it gives you something called data exploration and data definition. So let's go ahead and take a look at those. So I'm going to go ahead and open up the 2 auto-generated components, the definition notebook. So in the definition notebook, you can see that we have the what type of function did we use, and it goes in and explains some of the parameters and actually gives you the code that it generated to create that pipeline. It used a M5X4, and it tells you how many instances it used, what are the parameters, what are the configurations, goes through and tells you all the different algorithms that it used and how it used it to generate your model. And this is very useful because when you look at optimizing your model and looking to see what happened in the back end, what is my hyperparameters, you have a place where it shows you all that information. And this is called the model definition. And the other one is the exploration notebook. And in the exploration notebook, what that does is that provides you the actual data exploration. It shows you the sample data set, and it goes in there and does some statistical calculations to find out the number of unique. And then it also does descriptive statistics, gives you the mean, the median, the max, and the min. And it does all that feature engineering. And it tells you this is how I saw the data to process the data. And if you see it any other way, we can go ahead and adjust the parameters to get it done. Very powerful, and it takes a lot of the heavy lifting and optimization from the data scientist into a more autopilot mode. And that is the low-code solution. And the no-code solution is a fairly straightforward approach. All it really does with the low-code is you put the files in the S3 data lake. So they call the S3 the data lake. So this is the Amazon storage pipeline. So this is called a data lake. You dump your data into the data lake and you call the Lambda function. And once you call the Lambda function, what happens is it goes out there and runs the code and returns back the result. So in this case, I had to dump in two files. One is called the test and one is called the train. So I'm going to give it that 80-20 split, or maybe 80-10 split, and I keep the 10 for my testing. So I go ahead and put the data here. And once I put the data here, automatically the Lambda function runs. And that's the beauty of running it inside of SageMaker. You can run the Lambda function, which kicks off the machine learning job. And in this case, this is AutoML Lambda function. So let's go ahead and take a look at that function. So as you can see, here is your Lambda function, and these are the parameters and the code to run that Lambda function using the library. Again, parameters are already preset, and it generates the output. And once it's done, so you can see how very quickly you can get to the result. You just run the function and save the file in the S3 bucket. And then you just return out. A very straightforward way to run a machine learning without any coding. So all you have to do is put the files in there. And once you've put it in that S3 bucket and you run this Lambda function, it automatically triggers anytime a file is put into that particular folder. And that is here. You see where it says trigger and S3. This will tell you which location you need to put the file in so it can be triggered. So we're setting up that trigger for the Lambda function, and then we're running that Lambda function for AutoML. So if you look at the S3 bucket, for the code-free AutoML, we put the data in here. And as you put the data in here, it processes it and it comes back out. And then it puts the data in results. So there is two. One is the customer churn. The other one is the marketing auto glue-on churn. So the auto glue-on is a component that Amazon and Microsoft built together for automatic machine learning generation. So it's a very simple add-on that sits on top of the machine learning libraries like TensorFlow or MXNet. And it does the component. It's like Keras. It's an add-on library that was created by Amazon and Microsoft. So they have two components. One is the autopilot workflow, which you just saw, and then the other one is the auto glue-on component. So they have two different ways to do this. Okay, so looking at it from that perspective, so it does create the folder, and it gives you the customer churn rate and the test prediction. So let's go ahead and see how that looks very quickly. And I think we're almost done. You can see here, it takes your data and it says, this is the target and this is the predicted. And it kind of tells you, shows you which ones it predicted correctly and which ones it incorrectly predicted. And then you can go ahead and further look and see why. So it gives you that. And also it provides you something called a leaderboard. If you look at the leaderboard, it tells you, I used all these algorithms, all these machine learning algorithms. I used a neural net. I used a nearest neighbor. I used the, so it runs through and shows you all the algorithms that it used and tells you which ones have the highest accuracy. And I think that's beautiful. So now you can see, with all the permutations and combinations, it was able to come up to a 96% with this combination custom algorithm that it put together. And this is the power of machine learning, is that it can actually go out there and start doing all these permutations and combinations and trial and errors, trying to get that F1 score, trying to get that lowest score for you. And looking at this model, you can clearly see that it's very statistically rich, so it may not have the bias or some of these external factors input into it. But you can include those external factors as variables into the model. Okay, so this was the low code, no code solution, just putting it into the Lambda function and getting it completed. So from a high level, I just wanted to cover the 3 different approaches to predicting customer churn rate, and then essentially taking it into Tableau. It's straightforward to connect Salesforce Tableau directly to the Snowflake data warehouse, and then quickly run a report. So in this case, I was able to take that data, and then I was able to go ahead and quickly put a report with the zip code saying which particular states have a high risk of churn rate. And then you can see how different states have different churn rates, and you can take a look at it, and then maybe you can have a campaign manager go there and start figuring out how do we do an outreach for one of these states to figure out why there's a problem right here, why, and then kind of figure that piece out. But it at least shows you that area that you can focus on based on that data. Because if you just look at the data, you really can't see how what's happening with the customers. So when you sort it and when you count it and when you look at the prediction scores, then you come back here and you look at it, it just gives you a much more clear data-driven perspective of what's happening within this map, within the zip code for your customer churn rates. Okay, and that concludes our presentation for today. We looked at the data lake, the S3 library, how to upload the file. We looked at some feature engineering, and then we briefly looked at 3 different types of machine learning techniques that we can use Amazon SageMaker to perform. And then we connected the data from Amazon to the Snowflake data warehouse, and from the Snowflake data warehouse, we pulled it into Tableau. So that's kind of the pipeline that we used. Okay, that concludes our presentation for today. So we have about 10 minutes for Q&A. So if you have any questions, please let us know.